Hello, good evening. Can you hear me? Hello.
Yes, good evening, sir.
Good evening. Okay.
Hello.
Yeah. So can you hear me properly? Yeah.
Yes, sir.
Okay. So let me share my screen and then I discuss about the whole topic. Then you can easily understand about that how we can easily add the year of 2023 and also make the classification for the land use land cover time series analysis. Okay. So basically this is the code you send me. So in this time, this code I simply add the image for 2023. Okay, so just I simply you can see here the result about that previous land use land cover classes such as 2020, 2010, 2090. Okay, so in this time I add the another image land set 2023. Okay, so this is the image for 2023 I also add in here. So in this time what you can do, just you can see the same approach you can also apply in here. So first of all, simply open the map for 2023. You can see. So in this time, it open the 2023 satellite images. Just open these satellite images and then take the training point. Okay. So in this time, this image for the year of 2023.
Okay.
Okay. So now from here, you can simply take the training point. You can see. You can take the training point for the 19, and then 2000, 2010, and 2020. So in the same approach, you can also apply and take the training point. So just click on here and then suppose take the training point for, first of all you can see, take the training point for that water body. Okay,
What?
just simply click on here the water body. In this time simply put here water 2023. Okay, then also put here the feature collection property, same property we have to set. Suppose in this time class and set the value for 0 for water. Okay, so now we can take the training point for the water body. Okay, just take the training point for the water body and okay, check the class. Okay, okay, so it's the lower case. Okay, not upper case. So use the same property because it's the case sensitive. Okay, so that's why you have to use the same spelling or same uppercase lowercase will be same. So just I simply change it. I put the it's a lowercase. Okay, all of this property name will be same and set the 0 for water body. 0. Okay, and after that use different types of band combination. Okay, so which I already discussed in the previous class, how we can easily use the different types of band combination and then extract the different feature. Okay, such as water body, then cropland, then vegetation, barren land, build up area. So use here the different types of band combination from here and we can easily get the different types of feature from here. Okay, and then we can easily use the same approach. So after that you can take the training point. You can see, so take all of those training point one by one. Take all of those training points such as water, then take the training point for that forest, then agriculture, then barren land and build up. Total 5 class for year of 2023. Okay, so after getting this training point, what you can do, just you can simply go to the this option. Suppose you can see merge option. Okay, so simply take a variable. Suppose put the variable name is the samples 2023. Okay, then merge all of those training point for 2023. Okay, so after that suppose you take all of this training point and also merge all of this training point. After that you have to just make the train image. So take a variable. Suppose take the variable name is that, suppose train image 2023. So just simply paste and put the 2023 and then call the image 2023. Okay, and this image I already created. So here I create it, you can see I created the image in here, image 2023. So now this is the image 2023. So I simply call the image 2023, image 2023 I call, and then just I simply open the code. Where is it? Yeah, so image 2023 call and then use here the select function. Same approach, select and call the prediction band. Same, all of those things will be same. And then use here the float, float. Okay, so you also try to do. Okay, after that you have to make the classifier. So classifier training, just take a variable, suppose put the variable name is that classifier training 2023. Okay, 2023. Okay, then equal sign, then call the train image 2023. I already created that in here. You need to already create it about the train image 2023 and paste here, and then all of those things will be same. As well as you can see the sample, sample in this time put here the sample for 2023. Okay, and where you can get the sample, you already created the sample, you can see in here. Simply copy the variable name and paste here. Okay, so it also done about the 2023 for the creating the sample. Okay, so after that you can see here you need to merge. Suppose in this time I merged 90, then 2000, then 2010 and 2020. Okay, and in this time lastly you have to put the another thing is that merge, merge, merge. Just simply copy the variable name, simply copy the variable name from here. It's the classifier training 2023 and paste here. Okay, so another year we also add in here for year of 2023. Okay, so it also done. Then all of those things will be same. Okay, then all of those things will be same. Just simply we can make all of those pixel value for 90, 20, 10 and 22 and 23. All of those pixel value we can make a data set. It's our pixel value or a spectral signature. So now this data set I use here the 70% data for train and 30% data for testing. Okay, so after that all of those things will be same. Okay, and when you want to check you can get the accuracy all of those things. And finally when you want to add the map, just simply take a variable, suppose classified random rf. It's a variable name 2023. Okay, after that call the image for 2023. So just simply use here the img 2023 and all of those things will be same. Okay, suppose prediction classifier rf, all of this thing will be same. Okay, and finally you want to add the map.addLayer function. So for that you can simply just take a just put here such as map.addLayer and then call your classified image. So call this classified rf, simply copy and paste. Okay, and comma sign, and then all of those things will be same. Just simply copy from here, and put the layer name 2023. Okay, so now it finally created the land use land cover classification map for 2023 also. Okay, so in this time you do all of those things step by step. I hope you can easily created the land use land cover classification map for year of 2023 also, and also get the accuracy assessment. All of those things you can easily get. Okay, and also download the experiments. And when you download the experiments, what you can do, you can see for that you have to just simply copy the same code, and paste here, image classified image 2023. Okay, you can see I already created about this variable. Where is it? You can see, yeah, classified rf 2020. Simply copy this because it stored this variable, stored the image land use land cover classification image for 2023. Just simply paste here. Okay, and then suppose it is the fifth number of map we created. We can use any name, suppose for 2023, and all of them will be same. Okay, just do that, it also work. Okay, so in this time I send you this full code, so you also try to do. First of all, just simply take the training point for 2023, then step by step all of those things will be same across. Just apply. I hope you can easily created the map for year of 2023 about that, and also export it from here for year of 2023 map from here. Okay, so you have any question you can ask me. Any question you can ask. Yeah,
So,
please.
did you use any satellite images for this work?
In this time we are using the Landsat imagery, Landsat surface reflectance imagery. For
Okay,
the
so
Landsat 8,
Lancet 8,
Landsat.
7, and 5.
Okay, so basically in this time we use the Landsat 8 and 5, not 7. Okay, so basically you
Okay.
can see this is the
Sir, but in the code it's
LT5.
written Lancet 7 also.
Yeah, it's a variable name. We put it the variable name. There is no problem. But you can see here, this and this is the same. Okay, same image collection. Okay, it's a Landsat 5. You can see F05. Also, you can see the 05. Okay, it's a Landsat 5. In this time, we can take the image Landsat 5 and Landsat 8, and then make the combination. We just make the merge Lancet, all of those we can simply merge in here, and then we can simply make the annual collection. Annual collection means that in this time you can see here I put the time period such as year of 1992 2023, our last year. Okay, and then we can simply get the yearly annual image collection from here. Okay, so here we can get that when I merge all of those images, here I can get 258 images. Okay, for Lancet 8 and Lancet 5, two times Lancet 5, and where you can get total 258 images, and these 258 images I merge the annual image collection, total 34 years image collection from 1992 2023. All of this image collection we can create it in here. Okay, all of this we can create it in here. So you can see this is the image for 2023. This is the image for 2022. This is the image for 2021. Okay, and then I want to select only for the specific year. Suppose I need the year 2020, need the year 2010, need the year for 2000, and need the year for 1991, and I do some need the image for 2023. So which time you want to need, just simply select your year. Okay, and then do all of those things. Basically in this time we make the collection total 34 years image collection. From 34 years, which image I want to need, I just simply select the image and work the land use land cover classification map. Okay, in this time you want to get the more information about the Landsat imagery. For that, simply copy. Basically it's the image collection for the Landsat, and it is the benefit about the Google Earth Engine platform. You don't need to download any types of satellite imagery, because we can easily access all of those satellite imagery from here. You can see, just click on here. Here I can get all of this information. It is the USGS Landsat 8 level 2 data, and basically the data set provided is the USGS. Okay, basically United States Geological Survey. They provide the data, satellite data, and also we can get the data resolution 30 meter. Also you can get description about the data. All of those things we can easily get. Okay, so basically this is our satellite images for the Landsat 8 satellite images, and this Landsat 8 is
Sir,
that surface reflectance. We use here, you can see surface reflectance.
okay. Sir, so we have used Lancet 8 and Lancet 5 for this work.
Yeah, Landsat 8 and Landsat 5. And
Not
we are not
Lancet
using
7,
the
right?
Landsat 7 because Landsat 7 has some problem. This problem is that we can find out some scale line error. We did not get the proper images. So that's why in the your time period is the okay. There is no problem. So that's why you can use any image. There is no problem. Okay, because it fully cover my region. You can see about the Landsat 5. I simply open the click the Landsat image collection, and here you can see the Landsat 5. Click the Landsat 5. 1984 to 2012. Okay, so it's covered. So that's why I can get the proper
Okay.
image, then Landsat 8, Landsat 7. So that's why I simply use the Landsat 5. Okay, because basically this time we can get the proper image for the Landsat 5. For the surface reflections, you can see, basically we are using here the surface. This image you can use. And you can see time period is that 1984 to 2012. Okay, so it's covered, fully cover my time period. So that's why I can easily use the image and then work with that.
Okay, sir.
Okay.
Sir,
And
so I have to
yes.
exactly write the code as the previous years and then run.
Yes, previous class, all of this will be same. Just in this time, we
Okay.
add the another option for year of 2023. So in this time,
Okay,
all
sir.
of those things will be same for year of 2023. So take the training
Okay, sir.
point, then make the marks, then extract the pixel value, then all of those things you'll need to mark. So I send you the code. You can just simply follow this code one by one, and then you can simply take the training point for year of 2003 and make the classification. Okay? Then it
Okay,
will be
sir.
done. There is no problem.
Sir,
Yes.
actually, I'm doing my research methodology for this work.
Yeah, for the methodology, okay, so I also basically it's very easy.
Can you please tell me like stepwise, like whatever we have done
Okay,
for research
okay.
methodology?
So first of all, first step is that you can see in this time we use here the supervised machine learning method, mainly random forest. Okay,
What,
we
sir?
random forest classifier. We are using here the random forest classifier.
Random forest
Classifier.
classifier.
Okay, and first of all, we make the annual image collection for 1990, 2000, 2010, and 2023, 2020 and 2023. Okay, So all
Yes.
of those image, we can get the annual image collection. Use Lancet 8 and Lancet 5.
Yes.
Okay, so it's done. After that, we can simply take the training point. Because it is supervised machine learning method, you must take the training point. We take the
Yes.
training point for each classes, for water, forest, then agriculture, barren land, and build up area. We take the training
Yes.
point for each year, for each single year. Okay. After
Yes.
that, we just extract the pixel value, band pixel value. And in this time, which band pixel value I want to extract? Okay, you can see I already write about that in here. So basically, in this time, we just extract the pixel value for, yeah, blue band, green band, red band, near infrared band, short wave infrared one band, short wave infrared two band, and QA pixel band. We just extract the pixel value only for this band. All of those training point, extract all of those band pixel value. Okay. After that, we just simply, it's our training sample, and after it's our data set. When it's extract the spectral signature or pixel value, it's our data set. This data set we divide into two way. 70% data we use for train our model randomly, and 30% data we use for check our model or check the validation or testing. Okay. So now 70% data we apply here the random forest. Okay. You can see the training portion, it is a random forest. So 70% data we use for train our model. Okay. And 30% data we use for test our accuracy. Okay. Or validation about that. Okay. So after that, when I get my random forest algorithm, just my algorithm, I simply connect with my image. Suppose I connect the image, random forest algorithm connect the image for 90, then 2000, 2010, and 2020, and finally 2023. And now it predicts the land use land cover classification for total 5 classes. Okay. And for the accuracy, what you can write, you can see that it also created for the accuracy. Yeah. For the accuracy, in this time, it's the overall accuracy. Okay. So in this time, not for the single year accuracy, full. Suppose 2090, then 2000, 2010, 2020, all of those pixel value we can simply combine. Okay, and make the classification. So that's why in this time we can get the accuracy is that 99% about the accuracy, and it's our confusion matrix table. Okay, so 0 for, what is 0 for water, then 1 for, what is the one for forest, then agriculture, then barren land and build up area. So total all of those classes in here, it's a confusion matrix table. Okay, so from this confusion matrix table we calculated the accuracy for the some equation for the accuracy. When you just this value we can simply we calculate the accuracy. Okay, this value we can use, we can get the accuracy 99%, and also calculated the kappa accuracy 99% we can get. Okay, so then we can easily suppose, as well as you can simply download the tip images. You can see from the tip images, and I already show you the previous class how we can easily use the ArcMap software for calculating the area, as well as also show you that how we can easily make the change detection. Okay, so you also try to do that same approach for calculating the area and also check the change detection. I hope you can easily do that. Okay.
Sir, what is kappa?
Yeah, what?
Kappa.
Okay, kappa is a accuracy assessment technique. So you can see the kappa. I simply search the kappa, where used at the, for the accuracy we are using the kappa accuracy assessment. Okay, basically it used for the land use land cover classification accuracy. And basically you can see the accuracy assessment kappa. I simply open this site. Yeah. Okay, so PDF5 you can see accuracy, you can get a lot of information from here for the accuracy assessment, for the classification, how we can use the different types of classification for the accuracy. So in this time, okay, ground truth data with GPS, so aerial photo interpretation, GIS layer. So there are a lot of way for taking the reference data or accuracy assessment, as well as okay, just I for show you the formula about that. Okay, you can see the accuracy assessment kappa. So kappa is a statistic and estimate as a kappa value and reflects the difference between actual agreement and the agreement the expected by change. So kappa of 0.85 means that 85% better agreement than by change alone. Okay, and this is the formula about the kappa: observed accuracy minus change agreement divided by 1 minus change agreement. So in this time, observe, what is the observed accuracy, what is the change agreement, all of this information we can get from the confusion matrix table, which I already created in the Google Earth Engine code editor. So we can get this information from the Google Earth Engine code editor. You can see from this confusion matrix table, we can easily get, this is a confusion matrix table. We can easily get all of this, suppose what observed accuracy, change accuracy, and change agreement, we can easily get from here. When I put this formula, it will be showing a percentage. Okay, so this is the kappa percentage about that. And accuracy, you can see kappa, observed accuracy, change agreement. Okay, so observed accuracy determined by the diagonal in the error matrix. In the diagonal, what is the diagonal? You can see in this time, in this you can see diagonal. It's a diagonal. So this type of things we can easily get from here. Also, the change agreement in incorporates of the diagonal. Okay. So in this time, you can suppose you can see this also put the some problem you can see. So in this time, suppose suppose it's a water, vegetation, suppose build up area, water, vegetation, build up area. So in this time, they are also show about that how we can easily calculate it, the user accuracy, producer accuracy, overall accuracy. It's the overall accuracy 71%. We can get for the user accuracy for the suppose conifer, it's another types of feature. So in 88% for the hardwood, 48%, water for the 50%. It is the user accuracy. And we can get that producer accuracy 75%, 57%, 80%. And now what's the formula about that for calculating this type of accuracy? You can see, suppose you can see the formula, there's a lot of formula about that for the producer accuracy, yeah, reference source, user accuracy. In this time they are not applying this type of formula, just they are write this, but is some formula about that for how we can easily calculate it, the overall accuracy or producer accuracy. Okay, from the confusion matrix table. And in this time, this table you can see, this table called the confusion matrix table. Okay, it's a confusion matrix table, and this confusion matrix table is generated in here already. Okay, these are confusion matrix table. Okay, so in this time you can just suppose water, forest, on build up area, also put here the water column, forest column, build up area column. So just in this time you also write all of those things which I show you the confusion matrix table in the Excel file. Okay, suppose in this time it's suppose water, first row first column water, then forest, second row second column forest. Suppose 2 is the, what is the 2, agriculture. So agriculture is the third row and third column will be agriculture. Okay, then 3, what is the 3, 3 is that for the barren land, and it is the fourth column, and it is also fourth column, and fifth column build up area, and fifth column also build up area. Okay, the same things you can also write all of those things, and from here you can just simply find out, it's some statistical part. Okay, suppose you can simply search the Google, what is the accuracy formula, what is the user accuracy formula, what is the producer accuracy formula, how we can easily calculate the accuracy from the confusion matrix table. So it is a confusion matrix table. Okay, from that we can easily calculate the accuracy about that for a specific feature, as well as the total accuracy. Okay, and from the confusion matrix table we can also calculate the kappa accuracy. Okay, okay, so I will send you the code, you also try. I hope you can do it, and face any problem then you can also knock me, I also guide you, also send you the some paper about that, you can also read it, you can easily understand about it. There is no problem.
So our accuracy is how much percent?
In this time from this land use we can get the 99% accuracy.
So our accuracy we got 99%.
Yes, it accepted, there is no problem. Okay, and this accuracy generated from this confusion matrix table. Okay,
Okay.
you can get the very better accuracy in this time, there is no problem. And you also try to make the map for 2023 and also export this map from here. And further work you can easily do using the ArcMap software for representation of your map, also make the change direction and also calculate the area about that. Okay,
Okay, sir.
Okay, so I will send
Sir,
you the code. You can also try to that.
yes,
Yes. Any?
sir.
Yeah, please.
Uh, can you please send me like, can you please write down and send me the methodology of our works?
Okay, for the methodology, I can send you some reference paper. You also try to read about this paper. I hope you can easily get the idea.
Sir, like whatever works we have done, like accordingly.
Okay, so for that, you can also follow my research gate profile. For that, you can simply send you the link also. There's a lot of work we can do for using the land use land cover classification. So these are towards the understanding. Okay, assessing the and predicting the land use, land cover, land surface temperature, and urban thermal field variance index using Landsat imagery for the Dhaka metropolitan area. So this is another work for using the land use, land cover classification. Okay, as well as okay, there's a lot of work you can also get from here. So spatial temporal analysis, urban economic quality of urban area using the geospatial technique is another. Modeling the impact of the land use, land cover pattern, and urban thermal characteristics in Kuwait. It's identification of suitable and land for livestock production using the GIS-based multi-criteria decision analysis. Okay, so I have to send you the link also. You'll also try to follow this. There is no problem. Okay, and there not only for that, you can also get a lot of method from the other profile, other research paper, and
Okay,
also
sir.
get the information from here.
Okay.
Okay. Okay, so I'll send you that. You also try to do that. Okay.
Okay, sir.
Okay. Thank you. Okay.
Okay, thank you, sir.
Okay. Bye.